Section 3.6, derivatives of logarithmic functions. In here, the formula is the inverse of x multiplied by the natural log of the base of the log. So please do not confuse this formula with the derivative of a to the x respect to x. We have seen that before, that is itself a to the x times the natural log of a. So this formula is quite different from this one. To begin with, the natural log is in the denominator and in here is on the numerator. And also in here you have the reciprocal of the log, and here you don't, you have it itself. Naturally, if the base is e, I will have 1 over x times the natural log of e, but you know that the natural log of e is 1, so this just stays as the reciprocal of x. So we're going to apply what we know in example 1. I have the function y equals natural log of x cubed plus 1, so naturally they're asking me to find y prime. So y prime, I know that there are two functions going on here. I have the cubic function and then I have the natural log function. So I'm going to take the derivative of the outer function. Derivative of natural log is 1 over, in here is 1 over x. Since I don't have 1 over x, I don't have the natural log of x, I have the natural log of this function. So this is the function for which I'm writing the reciprocal of. Since it's natural log, that's where it should end. However, I'm applying chain rule, so I'm going to multiply that by the derivative of the inside, which will be 3x squared. Now, writing everything nice and neat, 1 times 3x squared is 3x squared over x cubed plus 1. Okay, in example 2, I'm going to take the derivative of this function. Again, I can mix trigonometric functions with logarithmic functions. That just adds the fun. So the derivative of the outer function would be the reciprocal. Since it's natural log, then I don't have anything else but the reciprocal. And chain rule will tell me to take the derivative of the inside, which will be cosine of x. Now when I multiply across, this will be cosine of x over sine of x, and you know that that is the reciprocal of tangent, which is cotangent of x. Now notice that if I'm finding the reciprocal of sine of x, it is not the arcsine of x, it's 1 over sine of x, or you may see it as sine of x to the negative 1, or you may see it as, no, I think that's the only notation, because if I put the negative 1 here, that means arcsine. So please do not confuse arcsine with the reciprocal of sine of x. This, if anything, is cosecant of x, but I'm just going to leave it as sine, because in that way I identify that this is cotangent. Okay, example 3, we are at 3 minutes and 18 seconds. This is great, this is going very quickly. F prime of x, the outer function in this case is the square root, so you know that the derivative of square root is 1/2 the inside to the negative 1/2, the inside being natural log of x, and then by chain rule I just have to take the derivative of this, which is 1 over x. Now, making it beautiful, the 2 and the x multiply, so I have 1 over 2x natural log of x to the negative 1/2. Now the book may say the following, that the answer also can be seen as taking the reciprocal of this, which is natural log of x below the divisor line, or in the denominator if you want to say that too. But then the 1/2 makes it have a square root. So this answer and this answer are both mathematically correct. This one is showing